Section 49-2 covers solving quadratic inequalities algebraically. Yesterday, we worked on solving these graphically. Today is algebraically. So here are your 5 steps for solving inequalities algebraically. I will do a couple of examples for you, and you will have to do a couple on your own. So for the first example, we have x squared minus 2x is greater than 15. According to the first step up above, we have to write this inequality as an equation equal to 0. So that means I'm going to be subtracting the 15 from both sides, and at the same time changing the greater than symbol to an equal sign. And notice I have this written in standard form because the next step is to factor, and factoring is easier once your equation is in standard form. So in order to factor x squared minus 2x minus 15, we have to think of two factors that multiply to be 15 and add up to negative 2. Those values would be negative 5 and positive 3. So x minus 5 times x plus 3, is the factored form of this equation. Now we take each of those binomials and set them equal to 0. And then lastly, we solve for our two values of x. Step 3 up above says plot the solutions on the number line. So that means I have to put my negative 3 and my 5. The smaller number needs to go on the left. The larger number needs to go on the right. And looking at the original inequality, the symbol is a greater than symbol. So that tells me we have to use open circles. So we would have this graph at this point. Now we have to test our regions. We've done this before. So test regions, I have to pick a value in the left section, the middle section, and the right section of this number line. Plug those into the original inequality. You always test using the original inequality. So let's say on the left side, in that furthest region, I pick negative 4. So I plug negative 4 in for all the x's. I evaluate that using order of operations. So I get 24 is greater than 15. That is a true statement, so I have the check mark next to it. In the middle region, I'll pick 0. So plugging 0 in and evaluating, I get 0 is greater than 15. That's a false statement. And then in the region on the right, I'll pick 6. Plugging 6 in gives me 24 is greater than 15, which is also true. So now part of this step with doing the test regions is shading the graph. You remember you shade anywhere your test points gave you true statements. So we have shading in the left region, shading in the right region, no shading in the middle. And then our last step is to write the solution from this graph. Solutions are always going to be compound inequalities for these types of problems. So since these two shaded regions are pointing away from each other, this is an OR compound inequality. So my final answer is x is less than negative 3 or x is greater than 5. Now I'd like you to do number 3. So now check your work for number 3. Make sure you have the correct compound inequality answer. X is less than or equal to negative 2, or x is greater than or equal to 4. Double check your graph that you have the closed circles shaded away from each other. If you need to fix anything, go ahead and adjust it. So the next one I'll do for you is number 4. Following the same 5 steps as before, First step is to write your inequality as an equation equal to 0. So I don't have to add or subtract anything in this case. Now factoring. Remember, the first step in factoring is to always look for a GCF. In this case, we have a GCF of 3x. So if I factor that out, that is the only step for factoring because x minus 2 cannot be factored anymore. Now I'll take those two factors and set them both equal to 0. That's using the zero product property. And then solve each one of those. You have x equals 0 and x equals 2. So now when we graph those on a number line, we'll have open circles on the 0 and the 2, and then testing the 3 points. The region on the left, I chose -1. I got 9 is less than 0, which is a false statement. The region in the middle, I chose +1 to test. Got -3 is less than 0, which is a true statement. And then the region on the right, I tested 3, and again got 9 is less than 0, which is again false. So based on these test points, I would be shading in between the numbers 0 and 2. And then to write my solution, my compound inequality, anytime in the graph that you're shaded between, that is an and compound inequality. So in this particular case, our and compound inequality answer is 0 is less than x, which is less than 2. So now your job to finish this lesson out is to complete number 5. Here is all the work that would be necessary to complete number 5, including the solution. Please check over all your work, including your graph and your final answer. Make sure everything is written the way you see it here. And then you may use any time left to start your homework.